Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at classifying quadrilaterals. Basically, we're going to group quadrilaterals according to their characteristics. So the first way we need to be able to group quadrilaterals is as to whether they're convex or concave. Note, concave just means not convex. So how do we do this? Well, it turns out a quadrilateral is convex if each of these is true. So convex quadrilaterals have no reflex angles. They have no angles bigger than 180. Secondly, all their vertices point outwards. So a vertex is a corner, plural of vertex is vertices. And when we say point outwards, we mean away from the center of the shape. So a quadrilateral is convex if all of its vertices point away from its center. And for number 3, both diagonals of a convex quadrilateral are inside the shape. I'll show you what that means in a second. But basically, a concave quadrilateral doesn't satisfy any of these. A quadrilateral is concave if it has one reflex angle, if it has one vertex that points to the center of the shape, and it has one diagonal that is outside the shape. So just note, all of these three are logically equivalent. That's a pretty hard concept to understand. It means that if one of these is true, all three of them will be true. You can't have a quadrilateral that has no reflex angles but has a diagonal outside the shape. So you only need to identify one of these points in order to conclude that a shape is convex, because if one of them is true, the other two will be true. Similarly, if only one of these is false, if you can just identify that one of these is false, that's enough to conclude that the shape is concave. So you only need to find one of these or examine one of these. Look at these two diagrams to see more what we mean. So this shape here is convex. So you can see firstly it has no reflex angles. There's clearly no angles here bigger than a straight angle, bigger than 180 degrees. Secondly, all its vertices point outwards. So these are the 4 vertices or corners. You can see that all of them are pointing out. They're all pointing away from the center of the shape, which is about there. So the third one's probably the trickiest to understand about diagonals. What is a diagonal? A diagonal is just a line that joins non-adjacent vertices. So these two vertices here, they are not adjacent. They're non-adjacent because they're not next to each other. These two vertices are adjacent because they're next to each other. So all quadrilaterals, no matter how weird looking they are, they have 2 diagonals. So the first diagonal is this line here. It joins 2 vertices that are not next to each other. The other diagonal of the shape is this line here. Again, it joins 2 vertices not next to each other. So we can see that both diagonals here are inside the shape. So all of these are true about this shape. That's how we know it's convex. What about this shape here? Concave. Well, we can see that this does have a reflex angle. So remember, a straight line's 180 degrees. So if I extend this line, this angle here is 180. So this whole angle here must be more than 180. This angle I've marked green is a reflex angle. So this shape has a reflex angle, it must be concave. So note that a quadrilateral can never have more than one reflex angle, because then the angles would add to more than 360, which we know can never happen. All right, let's look at this second point. So for this shape, these 3 vertices or corners do point outwards, but concave quadrilaterals have one vertex that points inwards. The center of the shape is about there. See, this vertex here is pointing inwards. So it doesn't satisfy this point. This point about convex quadrilaterals is wrong for this shape, therefore this is concave. So finally, let's look at the diagonals. So remember, diagonals join non-adjacent vertices. So this is one diagonal. So there's one diagonal inside the shape, but the second diagonal is here. It's outside the shape. These 2 vertices are adjacent, but these 2 are actually not, because there's a vertex between them. So once again, to show that a shape's concave, you just have to find one of these points that does not work. So I like the word concave because it actually does describe the shape well. Concave quadrilaterals are sort of caved in. See, it's caved in around here. That's a good way to identify them. So note all the quadrilaterals that you know, like rectangles, parallelograms, squares, all of that are always convex. If they're concave, they must be an irregular quadrilateral. You can never have a concave kite, a concave rhombus, or anything like that. All right, let's look at a bit more at classifying different quadrilaterals. So every quadrilateral on your screen here is convex. We're going to classify them, we're going to group them based on the number of parallel lines they have. So it's easy if a quadrilateral has one pair of parallel lines, then it must be a trapezium. So this shape here has one pair of parallel lines, the other pair of lines is not. So remember, trapeziums are always convex. So what about if a quadrilateral has no pairs of parallel lines? Well, there are two options. It could be a kite or an irregular quadrilateral. So basically, an irregular quadrilateral is just a quadrilateral that doesn't fit the definition of any of the others. An irregular quadrilateral is one that's not a kite, trapezium, parallelogram, not a rhombus, not a rectangle, not a square. So irregular quadrilaterals, sometimes they have equal sides, sometimes they don't. Irregular quadrilaterals can also be concave, but this irregular quadrilateral is convex. So if a quadrilateral has no pairs of parallel lines, but it has two pairs of adjacent equal sides, it's a kite. So remember, adjacent means next to each other. This shape here is a kite because it has one pair of sides that are next to each other and equal, two pairs of sides that are next to each other and equal. Just make sure you know the difference. Like rectangles have opposite sides equal, the sides facing each other are equal. Here we have sides touching that are equal. So for a kite, there's also always one pair of equal angles. And that's basically where the two pairs of equal sides meet. So what about if a quadrilateral has two pairs of parallel lines? Well, if that's true, then it's a parallelogram. So parallelogram has one, two pairs of parallel sides. Most people think of a parallelogram as a rectangle on a slant. So parallelograms also have opposite sides equal. That's what the dashes mean. They also have opposite angles equal. So these two angles are equal, these two angles are equal. But there are several types of parallelograms. So if you have a parallelogram where all sides are equal, then it's a rhombus. Any four-sided shape with all sides equal must definitely be a rhombus, which means it must also be a parallelogram. If you have a parallelogram with all angles equal, we know that as a rectangle. So because the angle sum of any quadrilateral is 360, if all four angles are equal, they must be 90 degrees. So the formal definition of a rectangle is a quadrilateral with all angles equal. And a square, probably the most famous of all the quadrilaterals, it's actually a rhombus and a rectangle. It's a rhombus because all its sides are equal, and it's a rectangle because all its angles are equal. So a square is actually a type of rectangle. A square is a type of rhombus. A square is a type of parallelogram. So all squares are rhombuses because they have all four sides equal, but not all rhombuses are squares because not all rhombuses have all their angles equal. It is a bit confusing, but don't worry, we will practice it. Just make sure you know this chart. So a square is a shape that's a rhombus and a rectangle, which also means it's a parallelogram. A rhombus is a parallelogram, but also satisfies the definition of a kite. A rectangle is a parallelogram. All rectangles are parallelograms, not all parallelograms are rectangles. All right, let's look at using what we know about quadrilaterals to find unknown angles. So let's find the unknown angle x here. So remember from previous video, the angle sum of any quadrilateral is 360. So I know all four of these angles must add to 360. But this is a bit hard because I have two unknown angles. But what we can do is use our knowledge of quadrilaterals. We know that because this has two pairs of adjacent equal sides, this shape here must be a kite. So we also know that for any kites, like I said on the previous slide, it has a pair of equal angles. It's basically where the unequal sides meet. So these two angles must be equal, and we need to know that to solve the question. Of course, 40 plus 80 is 120. So this angle here and this angle here must add to 240, because 240 plus 120 is 360. So I can call this angle here x, because both of them will have the same size. So I know that x plus itself, if you add it up with itself, you must get 240 degrees. Again, because 240 plus 80 plus 40 equals 360. So this is just an equation that says what number do you add to itself to get 240? Well, if you didn't know that, you could just divide by 2. 240 divided by 2 gives us 120 degrees. So it's 120 and 120, 80 and 40, because this shape is a kite, and we knew it was a kite because it has two pairs of equal sides that touch each other, and then we were able to use our knowledge of kites that the two angles are equal where the unequal sides meet. Alright, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.